Hello and welcome to our ELECOMP Capstone Fall 2023 virtual presentation. We are Team Aerocyonics and our project is Saint Dashboard Security Articles of Interest for Awareness, Outreach, and Actionable Intelligence. First, let's meet our technical directors for the project. We have Daniel Damasi, President and CEO of Aerocyonics, Ram Pav, Chief Engineer at Aerocyonics, and Isabella Johnson, Software Engineer at Aerocyonics and ELECOMP graduate of URI class of 2023. Now let's meet our ELECOMP capstone designers for this project. First, we have myself, Kyle Nadeau, a computer engineer, as well as Mara Corrado, another computer engineer. A quick overview of the company. Aerocyonics is based in East Greenwich, Rhode Island, and are experts in cyber physical system security, hardware and software assurance, and advances talent in topic areas such as artificial intelligence and advanced microelectronics. To understand the project motivation for Saint Dashboard, first we have to understand the articles of interest. Articles of interest are manually compiled 1,000 plus articles made by the company on a weekly basis. The articles consist of information relating to cybersecurity threats for that week. The final product of these articles of interest is a PDF document, usually consisting of 200 to 300 pages. The anticipated best outcome of the Saint Dashboard project is to automate the process of curating the articles of interest weekly. To do this, we will implement machine learning to the Saint software to automate the aggregation of articles, and also put them in a user-friendly, navigable database UI. The economic impact for achieving the anticipated best outcome for this project will save Aerocyonics time and resources weekly, avoiding them having to create the articles of interest on a weekly basis, and also offer an ever-evolving web-accessible dashboard offering users information on cybersecurity related topics. Key technical accomplishments towards the anticipated outcome thus far have been machine learning to assign mitigations for articles of interest, as well as machine learning web scraping bot to determine if an article is a mitigation link. Our overall project block diagrams thus far has been extracting information from the articles of interest, using that information to process and categorize in our machine learning tasks, and then sending the final product to the Saint Dashboard UI. My technical accomplishments for this semester has been selecting machine learning model to use throughout the project, building prototype machine learning programs to understand the functionality of the machine learning model, and also compiling mitigation datasets to finally optimize the machine learning program to fit Aerocyonics' needs. The machine learning model that I selected for this project was a bidirectional encoder representation for transformers, otherwise known as BERT. This model is particularly useful in natural language processing machine learning tasks. The reason why this was chosen over other machine learning models that benefit in this area is because BERT benefits from larger datasets, which we will certainly be working with using the 1,000 plus articles of interest. Also, BERT benefits from bidirectional learning, which will be explained more in the next slide. Take the simple phrase, "I love pizza." The BERT model is able to encode each word as a token to be understood in the machine learning program. The bidirectional learning aspect comes in the fact of the word love, for example, is able to be related to the word that comes before it, I, and the word pizza within the encoding. This is able to help the machine learning model to truly understand the meaning of each word in a single phrase. Making machine learning prototypes was the first step in understanding how to create a machine learning model to assign mitigations. First step was curating datasets to train the machine learning program on. This involves me making my own training datasets as well as taking some from online. The next step was then training the model on these datasets. If the training loop was completed, then we could output the training accuracy and loss as such. If not, parameter values to increase the training results would be updated, and then the model would once again be trained. Finally, to actually assign mitigations using this machine learning program, I had to create a viable dataset. This dataset for mitigations was created by using several cybersecurity databases which relate mitigations to their cybersecurity threats. Once the model was trained on this data set, I sent data from Saint into the trained model to assign mitigations to articles.
So now I'll be going in depth on my technical accomplishments for this semester. And I'll also be talking about me and Kyle's future technical accomplishments in order to successfully reach the anticipated best outcome of this project. So my first technical accomplishment was to do research into usable Python libraries for machine learning. I used a bunch of different Python libraries, try to get familiar with a bunch of them, but the one that we deemed fit and most usable was TensorFlow, as it is a staple for machine learning and it's just easily accessible, easy to use, and it works well with a bunch of different machine learning models. The next technical accomplishment was the creation of a website scraper prototype. Uh, these prototypes would simply get in a website URL, go to that website, and then it would bring back the data that I wanted the scraper to get. And so after a bunch of uses with that and just getting comfortable with it, we then created the scraper that would go through a list of URLs, go to the website, bring back the main data from the HTML script that the website was created in, and then we would clean up that data and prepare it to be used into the machine learning bot. Now, this machine learning bot is different from the one that Kyle mentioned earlier because this one was used to determine if a website is a mitigation source or not a cybersecurity mitigation source. So the process goes as follows. So here we load in the target URLs into the data set. We then process these URLs by going to the actual website of the URL and bringing back the data that we wanted, such as the main data and the article data if the website was an article. We then would check if there's any more URLs in the data frame to be accessed. If there was, we would just process the URLs and keep going. If there are no more URLs to be processed, we would then store this data, keep it ready to go into the machine learning bot. And after that, it goes into the machine learning bot, and this is where the categorization happens, in which the machine learning bot will decide if the website is a mitigation source or if it's not. Technical accomplishments towards the anticipated best outcome. The most important one and the main one is to automate the aggregation of articles. We have been working on this and we will continue to work on this until the very end of the project. This just helps reduce the amount of time and resources spent on making the articles of interest, as Kyle mentioned earlier. If we could turn this multi-hour process into a 30-minute or an hour process, that would be a huge success. The next key future accomplishment is to reduce the runtime of the Saint software. This involves just adding stuff to the program that would speed up the process. As an example, the current web scraper accesses the websites one at a time. If we could implement something like a web scraper that could go to 5 different websites at a time, 10 different websites at a time, that would heavily reduce the runtime. Another key future technical accomplishment is to add metrics data to the database. This will help in analyzing the effectiveness and efficiency of our project, and we can determine what's working and what's not working from the back end sort of things. And the final one would be improve the style and functionality of the UI. This one's a more of a front end thing in which we can make the dashboard as user friendly as possible. We can allow it to be easy use to almost anybody, and it would be an inviting program that anyone can use. And finally, we would like to send out a huge thank you to the CEO of Aerocyonics, Daniel Damasi, who set us up with this project and who assigned us our other technical directors, who we also would like to send a huge thank you to Braun Pav and Isabella Johnson. Week in and week out, they have been such a help for me and Kyle, offering help and good, positive pushes in the right direction when it comes to life in the real world and also in this project sense. We'd also like to send a thank you to Jamie Gagnon and Katie Tallman, who during our Tuesday sessions have been amazing. They've helped us out whenever there's a problem. And finally, we would like to thank a huge thank you to Dr. Sunak, who, without this whole capstone program, we don't get this invaluable real world experience. So we would like to send a thank you to everyone and thank you for listening.